Let alpha beta belong to real numbers such that limit x tending to 0 if this is equal to 1, then sets alpha plus beta is equal to 1 total. So, as you can see in this question, limit x tending to 0, x square sine beta x upon alpha x minus sine x. So if I put 0, the numerator and denominator both will be 0. So this is 0, 0 form. So now we'll just simplify this limit and just find the answer, right? Now this limit exists. Also we know that limit x tending to 0 sin x by x is equal to 1, right? So this is the basic definition which you have to remember in order to solve this question. Okay, so limit x tending to 0, x square. Now if I divide this numerator by beta x and multiply by beta x, sine beta x divided by beta x and multiplied by beta x, right? And in the denominator there is alpha x minus sin x. Now this will get cancelled because sin x by x identity, and limit x tending to 0, x square into beta x, which is basically x cube beta x now. Beta into x cube upon alpha x minus sin x. Now again this is 0 by 0 form, so I'll use the basic L'Hopital rule. So this becomes limit x tending to 0, 3 beta x square upon alpha minus cos x. Okay, so those of you who don't know what L'Hopital rule is, so basically if a limit is in 0 by 0 form or infinite by infinite form, uh, we use L'Hopital rule in that case. In that rule, basically what we have to do is we have to differentiate both numerator and denominator separately, not by the quotient rule, but separately. Okay, so that will simplify things. So that is the L'Hopital rules. So yeah, again, now if I put x is equal to 0 again, so this will give me that the numerator will be 0 and the denominator will be alpha minus 1. Also, by basic definition of limit, we can say that if a limit exists, it has to be indeterminate for the limit to exist, right? So it will be 0 upon something. This is not an indeterminate form. This is equal to 0. But in our case, the limit is 1. So this means that the denominator has to be 0, right? This means that this alpha minus cos 0, which is 1, alpha minus 1, this should be equal to 0. So I get alpha minus 1, this should be equal to 0. This implies that alpha equal to 1. Okay, so I got alpha equal to 1. Now I just have to find beta. Okay. I can substitute the value of alpha in this case only. Alpha is 1. Now I'll just use the normal identity that 1 minus cos x limit. We know that 1 minus cos x is equal to 2 sine square x by 2, right? So limit x tending to 0, 3 beta x square upon 2 sine square x by 2. Now I'll divide this by x by 2 whole square and multiply by x by 2 whole square. Why? Because this thing will get cancelled by using this identity, right? So now I got limit x tending to 0, 3 beta x square upon 2x square by 4, which is equal to 1. So x square and x square get cancelled. So 1, 2, 6 beta is equal to 1, and beta equal to 1 by 6. So now I got that alpha is 1 and beta is 1 by 6. So we have to find 6 times alpha plus beta. So 6 times 1 plus 1 by 6. This becomes 6 into 7 by 6, which gives us 7. So the correct answer is